All right, I'm here today to talk about leveraging Gradle to automate the world of continuous everything at Nike. Maybe. Or my Mac is going to crash. That's awesome. I know. I've never seen PowerPoint crash on a Mac. Awesome, thank you.
Make sure you drop that at the registration desk when you go. Are you all set?
Yep. Huh? All right, let's try this again. All right, so as I was saying, I'm here to talk about leveraging Gradle to automate the world of continuous everything. And quick agenda, I'm going to talk about how we're using Gradle at Nike from everything from bootstrapping new projects to enabling the local development of a complex microservice system to enabling continuous integration and continuous delivery and where we're heading. So a little bit about me. I'm a senior software engineer at Nike. I've been with them for about a year. I'm a diehard Beaver fan, and I have a couple multi-poos, and I love everything that runs in the JVM from Gradle to Groovy to Grails. I have my LinkedIn profile here and my Twitter handle and my email address, and my slides are uploaded to the schedule, so feel free to download them and connect with me later. And a little bit about Nike Consumer Digital Tech. We're an organization that's evolving right now. We're Nike.com, Nike Plus, the sneakers app, a bunch more Android and iOS apps, and all the APIs that support all that and all the marketing campaigns we have. Right now, we have a bunch of legacy servers and monolithic apps and release cycles, and we're migrating to the cloud, microservices, continuous delivery. So our goals right now are really to reduce time to deploy, time to test, time to fix bugs through automating everything. So a little overview, high-level overview of the architecture that we're moving towards. We're heavily leveraging the Netflix open source stack. We're using Asgard, like was discussed earlier today. It's a wrapper around AWS. We're also using Eureka, which is another Netflix OSS product that enables service discovery, and Ribbon, which is a mechanism of talking to Eureka and other microservices with failover and built-in load balancing. Zool, which is a wrapper which does routing, so all the front-end requests goes through Zool, and it'll use regex or whatever mechanisms to route requests to the appropriate microservices. We're using Couchbase and Cassandra and Jenkins and Gradle, obviously, and Stash. So the first piece of continuous everything in our world is bootstrapping a new project. So we're utilizing Groovy and Grails, and we're being pretty successful right now. At a high level, this is what it looks like. So a developer who wants to get started will check out a Groovy script, and they'll run a Groovy command, and they'll just give it a location, a name, and a template type. And depending on the type, it'll go to Stash, and it'll just check out a template, and it'll do some simple searching and replacing and setting up the boilerplate code. And then you have a new project on your local machine, and it triggers a post setup script, which will trigger a couple Gradle tasks. And basically, what we've automated in the Gradle plugin is configuring the application infrastructure in this application.yaml. So we try to define everything you need to know about an application in this file to deploy it from scratch. So all the infrastructure, like, does it have S3 buckets it needs? Does it need data stores? Does it need an ELB? Does it have Route 53 work that needs to be done? All that stuff is defined in this YAML, and I'll show an example of that on the next slide. But we then take that YAML and we use it later on. The next thing we do in the Gradle plugin is we create the stash repository, and we do the initial commit, and then depending on what type of project it was, from reading the YAML file, we'll go ahead and trigger a pipeline to get created in Jenkins, and we're using the Jenkins Job DSL plugin right now, and that's a really, really cool plugin that for Jenkins that enables you to define your jobs in Groovy. So you can, adopting that whole infrastructure as code thing, you can define what your pipelines are in these Groovy files, and this plugin will just read them and then generate jobs out of them on the fly. So we have several base pipelines that are defined, and depending on the project it is, it'll just generate it for you, and you can teams can override it how they see fit. And then after that, we ping back to Stash. We have another plugin we wrote for Stash, which is the Stash CI/CD plugin, and we wire it up to point to the newly created pipeline. So just from running this Groovy script and executing a couple of the Gradle tasks, you now have a project that exists in version control, and there's a pipeline for it, and it's all hooked up for continuous integration and continuous delivery right out of that, so they can make a pull request right away, and it'll kick off a job, or they can, if they merge a pull request to master, it'll deploy it to by default to test automatically. So I'm going to dig in a little bit to that first piece, which was the infrastructure as code. So this on the right is an example of what the YAML looks like. So we're just defining all the pieces we need to basically interact with Asgard. And right now we have it, it's not 100% automated on our end. There's it is automated for your basic simple microservices, but if you are using S3 or you need an ELB and you're not just going through Zool and Eureka, then you have to do some manual steps the very first time, and we're working on automating that. So the seed job that I was talking about, so our plugin basically just hits Jenkins via REST and fills out the form, and it generates the pipeline. Nothing too crazy about that. The next piece in the continuous everything puzzle is local development. So when you have that crazy microservice world where you're trying to develop microservice A and it depends on B and it needs Eureka to find B, it can get a little bit complicated to develop locally in a sane manner. We use Gradle to create a few plugins to enable developing cloud-based microservices locally a little bit easier. The first plugin is the Gradle Growler plugin, and basically this plugin manages a Vagrant machine that is running Eureka locally. It's also running another microservice called Kingpin that we wrote, which enables us to stuff whatever we want into Eureka, including metadata. And the way that Vagrant box is set up is we can easily add more wars to it as we see fit. So this plugin has all the tasks we need to bootstrap that Vagrant box if it doesn't exist, update it. There's a task that'll block and wait for the health checks to pass, so you know the Eureka and Kingpin are up and running before you do stuff. So the cool thing about it is with Eureka, Eureka uses carry-on apps, and carry-on is another thing that Netflix created, but it's a framework, and when a carry-on app is up and running, it tells Eureka, hey, I'm alive, I'm ready to start taking traffic. So we can inject mocks or anything we want into the local Eureka just by defining a closure, and I'll show you the interface for that in a couple slides right here. So we can define this closure block and say, oh, I'm going to develop service A, I really need a service called Metrics Writer and a service called Graphite API service to exist in Eureka, because my service is going to go look for those. So I just define this this configuration block, and when I run Gradle register, it'll bootstrap that Vagrant VM, and when everything's said and done, these two services will be inside Eureka. And this plugin goes hand in hand with another plugin we created called Gradle API Mocker. The Gradle API Mocker plugin takes these API markdown files. So if you've never seen an API markdown file, this is what it looks like. And it's basically just a way for you to define your API contract in a markdown file that's easy to read, but it's also machine parsable. So for example, this markdown file is defining a REST endpoint on /message, and if you do a GET call to it, it'll return a 200 response in plain text, hello world. So we're following the practice of defining these markdown files for all of our microservices. So the cool thing is since they all exist and the technology exists out there to convert a markdown file into a machine parsable YAML or JSON file and create a mock server out of it. So we wrote this plugin where you can point to a URL or a local file and pull in those markdown files and generate a local running service that's just going to serve up those responses. So it's for happy path stuff where you don't need state and you can just return a static response. You can use this plugin in combination with the Growler plugin, and you now have a running little microservice environment that's just serving up static content. Another plugin we created for the local development environment is the Couchbase plugin, which we use for microservices that depend on Couchbase, and it allows us to, it's another plugin that utilizes Vagrant. So we can create a Couchbase, we can add buckets and views to it, and we can inject test data or reset the test data and destroy the test data. There's tasks in this plugin to take the data you have in your database and back it up so other people can use that test data if you need to generate test data for your fellow developers. So putting that all together, if you were developing Service A like I was hinting at earlier, you could use API Mocker and Growler and create a task like this one called Run Local with Mocks. And I put it in the local group and I gave it a little description, and I just say that it depends on API Mocker run, which will start that local running service that's serving up the content out of those MD files. And I say it depends on Growler register, which will make those that content show up in Eureka. And then I say it's finalized by Jetty Eclipse run. So I just type in that, or run local with mocks, and we sometimes do run local integration tests with mock or functional tests, wherever you want. And I just type that task, and all that stuff happens automatically for me. So if it's a brand new developer who just needs to get going, they just download the project, run this task. And if the microservice happens to need Couchbase, you just add depends on Couchbase bootstrap in there as well. So this is what it looks like in a pretty picture, because I know everyone likes pictures. You'll notice that all the API Mocker stuff is separate from the Growler stuff. They don't necessarily depend on each other, because the Growler plugin, you can just stuff whatever data you want in there. It doesn't actually have to exist. So you can run these two in parallel to get things started. So whoops, do you want to, okay, this slide, I did upload the slides. So the mocking is nice, but sometimes you want to integrate locally with real services, and you don't necessarily want to use services that are in a test environment, because we're really trying to not have an always-on test environment. We're trying to make it ephemeral, so it only exists when you need to test something and then you destroy it. So we are starting to explore Docker as a solution to enable more of a real production environment locally, rather than just using the mocks. So the next piece in the continuous delivery puzzle, or the continuous everything puzzle, is continuous delivery. And it's obviously been all the hotness in the industry right now. Everyone I feel like almost half of the talks here have been about continuous delivery. I would like to mention that continuous delivery is more than just technology. Just because you can do continuous delivery doesn't mean it's going to be possible. It's a mindset. You have to design your software and think about the development process with continuous delivery in mind. Everything has to be machine testable, because if you have this long drawn out QA process, that's not continuous delivery. So you have to architect everything where it can actually just be tested automatically. So continuous delivery at Nike is looking a little bit like this. This is the high view picture. So when we bootstrapped that project and it created a pipeline, it's going to create a pipeline something like this. So we have the pull request flow. So in Stash, we hooked up this job to the pull request event listener. So when a developer makes a pull request, it'll trigger the pull request job, and I'm going to talk a little bit about this more in detail in a couple minutes. And then when the developers are satisfied with the pull request, they'll merge it, and it'll do WAR. We build an AMI every single time. We don't reuse any of the servers running. We just make a new one. So we have the old ones around. We just disable them or resize them to 0. So if something goes terribly wrong, we can bring them back really quick. So we always have the second oldest code base around, but it's just disabled and not taking any traffic. So we'll deploy, and we can integrate. We can do integration testing, and we can do a canary process where we're just monitoring it, making sure it's healthy. And if we have multiple environments, this will be a cycle where you'll deploy to the next environment. And if everything's good, you get it done. If any one of these things fail in the process, you'll go to the fail job. So we're enabling continuous delivery and that process via Gradle. We're heavily utilizing Gradle. So we have the Gradle continuous delivery plugin, and that's a bad slide, but basically we have a group of tasks that are the Asgard tasks. So they're wrapping everything that's important for us to do in Asgard, because Asgard, I do believe, was originally designed to be a UI. People go in there and they click around, they press buttons, but that's not continuous delivery. That needs a human to go, use their brain and go click stuff, and we want everything to be automated, obviously. So we have a bunch of Gradle tasks that wrap the wrapper, but they work. So we can go get the information about the application or the cluster. We can find out if there's already if it already exists, or do we need to bootstrap or do we need to go read the YAML and create everything in Asgard? And we have the tasks for deleting the old ASGs, or disabling them, or resizing them, or if you deploy dark, we have the tasks for enabling traffic to it. And when you enable traffic to it, it'll just tell Asgard to tell the application to be up in Eureka, more or less, because they're all interconnected. So before I go deeper into the other functionality that we have added to that plugin, I want to talk a little bit about the quality management assessment API that we've created. So part of continuous delivery, like I was saying earlier, is automating quality so that you don't rely on human beings, so you can have the same level of confidence that you have in your other processes in an automated fashion too. So we've created this series of microsystems that are our API, and we have these things we call racks. So these are microservices that we can just send, like the PMD, the find bug reports, the Covatura, the results of any security scans, any of the other static analysis stuff that generates a report. We just send it the report, and then it stuffs it in Couchbase, and then it will trigger an analyzation of those metrics, and we have an analyzing engine where we can give it English BDD rules, such as, given the metric code coverage, then I expect it to be greater than 80%. So if a developer commits code and the code coverage is 75%, when we go to get the results, we'll know that this is a failing candidate because it's violating that rule. And then the other part, that's like a build related. So once you actually get it deployed, and you're doing the canary process, we have the real-time metrics gathering and monitoring, and they'll go suck up whatever data sources are relevant. They'll go to New Relic, Splunk, Graphite, or whatever the metrics gathering source of the day is. It really doesn't care. We can apply those same sort of English rules towards any metric from any source. If one of those rules is violated, we can trigger an action. Right now, it's mostly just notifying, but we're trying to make this framework self-healing in the future. So if there is something that has happened that we know there's a response that'll fix it, we can just go ahead and automate that and do it. And we are allowing teams to choose what the actions are for violations of these rules. So if they just want to be notified all the time, then they can do that. Or if they want to have faith in the system and let it try to self-heal, they can do that too. All right, so in that continuous delivery plugin as well, we have all of the Gradle tasks that are involved for interacting with that API. Because we don't want to just have curl requests everywhere and execute as shell inside our Jenkins jobs, because that would get ugly really quick. And we're also reading things from the project and sending that data to the QMA as well. So we've wrapped all that up in a nice bundle of tasks to send that data to the QMA. So here's an example of what the pull request job would look like. So and all these are Gradle tasks. So when we start, we tell the QMA API, hey, here's a new candidate that someone's thinking about merging into master. And then we'll do clean build, and that'll do find bugs, PMD, it'll generate the Coverture report, anything else you have hooked up. If you're dealing with Groovy, it'll do CodeNarc, all that fun stuff. And then we take all those reports and we throw them into an S3 microservice we created. So we archive all the reports in S3 so we can do a statistical trending analysis on that stuff later, or just have it for historical reasons, because we really do the analysis in the QMA API. But we want trackback URLs, because we don't want to just leave stuff in the workspace and have it get deleted. So we take the trackback URLs and we stuff it into the QMA. And then we tell the API to analyze all that data, which is just running those English rules against it. And there's a whole series of defaults, sensible defaults. And if for some reason, they're all overridable on a per repository basis by just including feature files. And feature files are just those where you define the BDD rules if you've ever used Gherkin. And then once that's all done, if everything's good to go, we'll say, hey, we're done. If anything fails along this process, we just let the API know, hey, the build failed, and we try to send it data, because that way, when someone gets notified, hey, there's a candidate that failed, they know why. They don't have to go dig through a bunch of Jenkins jobs or console logs to find out what happened. They can just get notified easily. And then we take the data and we post it back to Stash as a pull request comment, because like what was said earlier, we don't really want people to have to context switch a lot, or we don't need developers to have to go to all these tools and worry about it. They can just use the tools they're used to using. And I'll show you what that looks like in a little bit. So we do utilize a lot of boilerplate code. And when you bootstrap that project, you get this QMA Gradle file, which the important part of this file is we basically add some code in there, and it could probably be abstracted to its own plugin, but whatever it is, what it is. We detect if the branch I'm building isn't master, then we tell all the check targets more or less to ignore failures, because we don't want the build to break if anything goes wrong. We don't want to fail fast. We want to let everything run and collect all the failures and give it to the developers all at once. So that's one really cool thing we're leveraging. And then the Gradle, or the Jenkins job that actually runs it, as you can see, is just running all those Gradle tasks that I pointed to you on that little chart. And here's the cool piece. So once the pull request analysis is done, we take all the results, we stuff it into a pull request comment. We give you a link to the dashboard, which we created, and then we also link back to all the reports, which we stuffed in S3. So you can go through version control, and you can look at every single pull request that was merged, and you can see all these reports. They'll be there forever. So the next piece of our pipeline is obviously the deploy job. Deploying once you have a good pull request, you merge it, and then it triggers the deploy job. And this is just the simplified deploy pipeline because we have it set up where you can have multiple pipelines. So I'm just going to show the simplified one. So this process, it just builds the war, makes the AMI, and then deploys. And if it deploys and it passes its health check, it'll roll the old one out. So it doesn't do the whole canary process. So the war job in this pipeline basically looks like the pull request job. We're calling the Gradle targets for creating the candidate and doing all the same static code analysis, and we're stuffing that into the QMA. But instead of injecting any results or ending, we're just triggering the AMI job. The AMI job's pretty boring. All it does is create an AMI that has our war in it and gets it registered, and so it's accessible via Asgard. So then the deploy simple job, this is where we utilize all those other tasks. So we have these two tasks where we just go and get the existing information from Asgard, and we save it as JSON files so we can just suck them up in our plugin and make decisions. So one decision, like if it doesn't exist, obviously we need to create the applications, and if the application exists but there isn't an existing cluster, then we have to save a new auto-scaling group, and that's just the way Asgard works, because you can't add a cluster you can't add another auto-scaling group to a cluster that doesn't exist. So we have all that abstracted away into the Gradle plugin, and then when it registers up, we just we enable the new one, and then if there was already an existing one, we disable it, and we know about all this from the JSON I was talking about. And if there's an oldest one, we delete it, because you can only have 3 auto-scaling groups per cluster. So we always just delete the last one. And all this is utilizing Asgard and Eureka, because Eureka will tell you if a new instance is up or if it's been disabled and it's no longer accepting traffic. So Gradle in the future of Nike. So where we're looking at right now is we really want to finish automating the manual configuration. So the S3 buckets, the Route 53 DNS information, creating data stores if we need them, all the other stuff that you have to do one time. We want to do it 0 times. We just wanted to be able to define it in a file that is our infrastructure as code. Just like we have our pipeline defined as code, we want all the infrastructure defined as code, so it's all reproducible. And we're going to continue to improve the CD pipeline and tools. I did want to take a minute to talk about Nike and FOSS, free and open source software. So we heavily utilize free and open source software, obviously, and we have a GitHub presence coming soon. So we want to contribute back to the community, because we don't want to just consume it and use it and then not give anything back, because that's bad. And it's not good for us or recruitment or anything like that. So you can follow Nike CDT on Twitter, and when we get that GitHub page live, we're going to let people know, and we're going to try to, I would like to see a bunch of those plugins open sourced, and there's other stuff we want to open source. And we want to make pull requests back to the community, because you guys are producing really awesome tools, and we're using them, and we fix them internally, and we can't give that code back, but very soon we will be able to. Special shout out to Jenkins and Gradle and Netflix, because we're heavily utilizing all 3 of those to enable continuous delivery at Nike. So yeah, in conclusion, Gradle and Groovy are pretty amazing tools. And we're using them to automate everything from bootstrapping the projects to enabling the local environments to microservices, or to developing local microservices and creating the pipeline and enabling continuous delivery. So I highly recommend Gradle if you're not using it and you're just here to see what it's all about and thinking about using it. Do I have any questions? Yeah, we're using CloudFormation right now. In what aspect? Like to instead of using Asgard? Yeah, so there is plans, depending on priorities and manpower, to remove Asgard out of the picture and have some sort of system that uses CloudFormation, possibly. We use Puppet. It really depends on who you talk to because teams can do whatever they want. So different teams will use different stuff. There's a happy path, and then you can do whatever you want if you don't want to be on a happy path. Anyone else? No? Awesome. Yeah, that's fine. Oh, go ahead.
The pull request event listener, is it in Stash or is it in JSON?
Yeah, no, okay, so the way the pull request event listener works is we have a continuous delivery plugin that we created that's in Stash. So when a developer creates a pull request, it's a push system because there are polling systems, but polling doesn't necessarily scale. So we have Stash configured through the bootstrapping process to know what jobs it needs to notify. So Stash will tell Jenkins, the job in Jenkins, hey, you should run. And here's a bunch of parameters. Here's the from branch, the to branch, here's the authors and the approvers. So that way you have the full audit trail and everything. So it's just a build with parameters.
So you generate the pull request in Stash?
Yes. It notifies Jenkins. And then Jenkins, through our Gradle plugin, notifies Stash back. So it is a cycle. So that way, as a developer, I can just go to Stash and know what the status of my build is, and I can see the results of the build injected as pull request comments. Yeah, I would love to open source that whole flow because I feel like people would use it.
Yes.